Hello and welcome to the very first lesson of physical sciences. So kule video sizodiscussa i-organic chemistry, right? So before sithoma funa ukuthi siqale ama-exam guidelines. So lapha mkabi nginama-exam guidelines waka matric we-physical sciences. So ama-exam guidelines uwasebenzise for prepare for ama-exam, right? So they can guide you ukuthi ufocus kuphi when you are studying or when you are preparing for your exams. So for example, firstly they are divided into two sections, paper 1 and paper 2. Paper 1 is physics and then paper 2 is chemistry. So thina sizwakule chemistry since we are currently focusing on organic chemistry. So paper 2 is chemistry, right? So I recommend that you use this when you are studying, so they will sort of guide you on which areas to focus on, which key points you should note down when you are studying, and also they contain definitions which are more often used on ama-memorandum ama-exam papers. So ama-definition lawa lana ilawa bawasebenzisa kaningi maba create ama-memo walama-exams. Okay, so sizoya ku section ye organic chemistry. So intermolecular forces are also part of the organic chemistry. We'll come back to these ones. And then here we have organic molecules. Now this is the section that we are interested in. Okay, so here kuma exam guidelines uzobona ukuthi they are sort of like listing ama key points or key areas that you should focus on, right? So now check out these first bullet points. It just sets out ukuthi you have to define organic molecules as molecules containing carbon atoms, right? And then also ufunde organic molecular structures, functional groups, saturated and unsaturated structures, isomers, and you have to write down the condensed structural formula and molecular formula of these functional groups, right? Okay, so you have to be able to define these terms here: molecular formula, structural formula, condensed structural formula, and so on. So mina into engenza ukuthi mangifunda, or just like first ngiqale ama-exam guidelines ngibona ukuthi okay athini, and then I know ukuthi masengiya ku textbook sengiyazi ukuthi okay which areas I need to focus on, because lama point abawalistela kuma-exam guidelines yiwo ama-point abawafocus kiwo mabaseta i-exam, right? So nalama definition la kuma-exam guidelines yiwo ama-definition abawasebenzisako maba-create i-memo. So yeah, kungakusiza ukuthi uwasebenzise ama-exam guidelines not just for physics kuphela, even for maths or life science or geography or any other subject onayo. My-exam guidelines ayasiza, right? So yeah, ilokho bengikusho ama-exam guidelines uwafunde now just like i-textbook nje. And then also prepare for your exam, make sure ukuthi wonke ama-definition alawo yawazi, because they normally use these definitions here, right? So now let us jump into our notes. So ngizosebenzisa ama-notes from Mind the Gap, which is available for free ku Department of Basic Education's website, right? So as an introduction, I'll just read through this. Yazi ukuthi kusesenokweza ukuthi vele senikude ku-organic chemistry since mhlawumbe senithomile ngayo vele, I guess eklasini senidiscussile, maybe you are looking at other things ku-organic chemistry, right? So from my side, I feel that it's also necessary ukuthi nami nginikeze a brief intro, so that when we discuss papers I can actually refer back to our notes with okay, this we discussed and this is how we apply the concepts in an exam situation. So The aim of my video is to focus more on answering question papers, and yeah. So before say answer my question paper, I think it's necessary to briefly look at the theory, right? So yeah, as an introduction, I'll just read through and try to explain some of the concepts as I read through. So here we're looking at organic compounds and macromolecules. So organic chemistry is the chemistry of carbon compounds in living and non-living systems, right? So organic chemistry, or organic molecules rather, these are molecules containing carbon atoms, right? So yeah, any compounds are a carbon atom, they are described as organic molecules, except for these ones here: carbon dioxide, carbon monoxide, carbonates, and cyanides are the exceptions because they are considered inorganic compounds, right? So organic compounds typically have a backbone of linked carbon atoms that other atoms attached to. Okay, so here they're talking about chemical bonding. The organic compounds that we study consist of carbon atoms, hydrogen atoms, oxygen atoms, and the halogens, which are bromine, chlorine, and iodine, right? So which are often represented collectively as atom X, right? So carbon has 4 bonds. It's always surrounded by exactly 4 bonds. This is because carbon has 4 valence electrons, right? So yeah, and then oxygen has exactly 2 bonds. This is because oxygen has 2 valence electrons. Same applies for hydrogen and the halogens, right? So valence electrons, they are introduced at grade 10. I can't remember the exact definition of valence electrons, but it has to do with the electrons that are in the outermost shell of a carbon of an atom, right? Those are the most reactive electrons in chemical reactions. The valence electrons are the ones which are actually are the electrons which actually like participate more, or they are more reactive during chemical processes or chemical reactions. Okay, so yeah, now they talk about homologous series. Now these are the definitions that you need to know. A homologous series, this can be actually asked in an exam. Okay, define what the homologous series is, what's a saturated compound, what's a functional group, right? A homologous series is a series of compounds or molecules that has the same general formula and the same functional group. Each member of a homologous series differs from the previous member by a CH2 group, right? So that's just the definition. So homologous series, homologous series, they are talking about compounds which have the same general formula and the same functional group. Just like here, homologous series name, for example, alkanes, they have the same general formula and the same functional group, right? Same for alkenes, they have the same general formula and the same functional group. Yeah, and so on and so on. That's a homologous series. And then saturated compounds are compounds in which there are no multiple bonds between the carbon atoms in their hydrocarbon chains, right? So a hydrocarbon, before we discuss saturated and unsaturated, this is how they define a hydrocarbon in the exam guidelines. A hydrocarbon is, let me just look for the definition. A hydrocarbon is an organic compound that consists of hydrogen and carbon atoms only. That's a hydrocarbon, right? So when you're defining saturated and unsaturated compounds, you would say a saturated compound is a compound in which there are no multiple bonds between the carbon atoms in their hydrocarbon chains, the chains which have hydrogen and carbon atoms. All right. And then an unsaturated compound is a compound with one or more multiple bonds between carbon atoms in their hydrocarbon chain, right? So when you see a double bond or a triple bond, know that compound is unsaturated, and then the one without any multiple bonds is a saturated compound, right? The saturated compounds are less reactive during chemical reactions, and then these ones, the ones with multiple bonds, double or triple, they are more reactive during chemical processes or chemical reactions, right? Now they define a functional group as saying a functional group is a bond, an atom, or a group of atoms that determines the physical and chemical properties of a group of organic compounds. So a functional group enables you to identify a compound or to identify a homologous series, right? So, or to be able to say, okay, this compound belongs to a certain homologous series. For example, if you see a double bond, this is sort of like a functional group. You will know what I see a double bond between the carbon atoms, therefore this compound is an alkene, right? If I only see single bonds, I'll be able to say, okay, this is an alkane. If there's carbon atoms and hydrogen atoms and no double or triple bond, then this is an alkane, right? So if I see a halogen, which is bromine, chlorine, and iodine, I'll be able to say, okay, this belongs to halogenes, right? So that's what a functional group is. It enables you to be able to identify, okay, this compound belongs to a certain homologous series, right? So for example, if you are looking at the molecular structure of alcohols, you will see, okay, there's OH. That OH is a functional group, right? Because it can tell you, okay, this is an alcohol, right? And then when you look at aldehydes, you'll see OCH or CHO, right? You'll see this part here, this part, right? This one will, when you see this, you'll be able to say, well, okay, this is an aldehyde, right? So when you see when you see this one, okay, OCOH, you can say, well, this is a carboxylic acid, right? So that's a functional group. Le ekwenza ukuthi identify ukuthi this is an alkane, this is an alkene, or this is an alcohol. That's a functional group. Okay, so probably by now I'm sure what you know how to name organic molecules. You know what the condensed structural formula is, and then you know what's a molecular formula. If you just look at the exam guidelines, I think they define those. They say, okay, let's see, a condensed structural formula, they don't define what they do. A structural formula of a compound shows which atoms are attached to which within the molecule, right? It's the same with the condensed structural formula, except with the condensed structural formula, they don't show every single line which determines the bond, right? Hope that makes sense. So yeah, in a structural formula, all the bonds in the compound are shown. If any of these bonds are omitted, it is called a condensed structural formula, right? For example, this is a structural formula. They show all the bonds between the atoms, right, by vertical and horizontal lines, right? So here, this is a condensed structural formula. Okay, so yeah, a structural formula has all the bonds shown in the formula, right? They are shown by vertical and horizontal lines. The bonds between all the atoms are shown, right? So in a condensed structural formula, the some of the bonds are omitted, right? so they don't show every single line which indicates a bond between the atoms. Okay, so now we move on to isomers. So isomers, in isomers, the same atoms are used in different compounds, but they are assembled or connected in different ways, right? So isomers are compounds with the same molecular formula but different structural formula, right? So if the structures of the compounds are arranged in different ways, but they are the same number of atoms for okay, so let us look at an example. So if you have CH4, sorry, if you have C4H10, this is a molecular formula, right? And then this is a structural formula. And then you can see with the, okay, this structural formula also has the same molecular formula. So this is C4H10, C4H10, same molecular formula, right? But then look at the structures of these compounds. They are different. So those are structural isomers. Structural isomers have the same molecular formula but different structural formulas. So here they define structural isomers as compounds with the same molecular formula but different structural formula, right? So there are types of structural isomers. You'll have chain isomers, positional isomers, and functional isomers. So chain isomers are molecules with the same molecular formula and in the same homologous series but different types of chains, right? So this is a chain isomer, for example. This chain structure here is different from this one, but the same, but the molecular formula is the same, and these two compounds belong to the same homologous series, which is the alkanes, right? So which is why they're saying chain isomers are molecules with the same molecular formula and in the same homologous series but different types of chains, right? Okay, so positional isomers. So positional isomers are molecules with the same molecular formula and in the same homologous series, but the position of the functional group is the one which differs, right? For example, if you look at these two structures here, we'll see what the OH functional group in this one is attached to the first carbon atom, whereas in this structural formula here, the OH functional group is attached to the second carbon atom. So what is the difference between these two structures? The difference between these two structures is the position of the OH group. Here the OH group or the OH functional group is attached to the first carbon atom, so it's in position 1, whereas in this one is attached to the second carbon atom, so it's in position 2, which is why it's positional isomers, right? So same molecular formula but different position of the functional group. So they say positional isomers are molecules with the same molecular formula and in the same homologous series. Both of these are in the same homologous series. Both of them, they are alcohols. Their molecular formulas are the same. Check. See, their molecular formulas are the same. It's C4H10O. It's C4H10O, and it's C4H10O. It's C4H10O, but the position of the functional group is the one which is different. So which is why they're saying they are positional isomers, right? So those are positional isomers. Okay, so they are in the same functional group. Sorry, they are in the same homologous series with the same molecular formula, but the functional group is positioned differently. Molecules with the same molecular formula and in the same homologous series, but the position of the functional group differs. Okay, and then we also have functional isomers. So Functional isomers. Functional isomers are molecules with the same molecular formula but in different homologous series or have different functional groups. For examples, ketones and aldehydes, right? So the structural formula of ketones is this one. You'll see what, okay, the molecular formula is the same. The molecular formula is the same, but the structure is different, right? So here the oxygen atom is attached to the second carbon atom, whereas in aldehydes the oxygen atom is attached to the first carbon atom. So this is a ketone, this is an aldehyde, right? So yeah, the molecular formula is the same. Okay, so the molecular formula is the same. Those are structural isomers. They have the same molecular formula but different structural formula. Okay, so those are functional isomers. So this is an activity. I want to rush to question papers. Right, so now naming conventions or the naming rules, the IUPAC naming system. Right, so each IUPAC name consists of three parts: the prefix, the root, and the suffix. Okay, so I won't go much into detail with the steps or the rules of naming organic molecules. We will get used to them as we do more questions. Okay, so yeah, Lana said ruler, and this is an example. Okay, more naming. So now the physical properties and the structures. Right, so the structure of an organic compound. So the physical properties and structures. So the structure of an organic compound does have an influence on its physical properties as well as the chemical properties, right? So the structure of an organic compound includes the order in which the atoms are arranged in that compound, as well as the forces that are present between the different molecules. Okay, so these have an influence on the physical properties of that compound. These physical properties include boiling point, melting point, and vapor pressure above a liquid organic compound. So in the following section, the influence of the structure of molecules and its physical properties is discussed, right? So here we discuss how the structure of a molecule, or how does the structure of an organic compound affects its physical properties. How does the structure influence melting point, boiling point, and vapor pressure? Okay, so yeah, well, one main thing which affects all those properties, the intermolecular forces between the molecules of an organic compound, right? So the atoms which are key to intermolecular forces in this section will be carbon, oxygen, and hydrogen. So intermolecular forces that act between different molecules of a compound are called Fundivals forces. Those are the intermolecular forces that act between the different molecules of a compound. Okay, so let us sort of like try to visualize what we are talking about here. So when we're saying molecules of a compound, okay, let's say we have what can we say? Let's say we have water molecules, right? We have water. We have water in a container, right? And then there are water molecules. So this is H2O, right? This is H2O. These are H2O molecules. These are water molecules. Between the water molecules, there are intermolecular forces, right? So there are forces that act between the water molecules. So the molecules of the same compound have intermolecular forces between them. That's why they are saying intermolecular forces. So it's forces acting between the different molecules of the same compound, or yeah, it's forces acting between the different molecules of the same compound. So this is water. It has different molecules. There are forces that act between those different molecules of the same compound, right? Okay, I hope that makes sense. So that's why it's called intermolecular forces. So intermolecular forces that act between different molecules of a compound are called Fundivals forces. In the organic chemistry that we study, there are primarily two kinds of forces, namely the hydrogen bonds and the dipole forces. Okay, so Fundivals forces are the intermolecular forces that act between molecules of the same compound. So they are divided into hydrogen bonds and induced dipole forces or dipole forces, right? So induced dipole forces are when two molecules come very close to each other, right? So when two molecules come close to each other, the electrons move and the distribution of the electrons in that molecule will shift, so that there is slightly a positive side and a slightly a negative side on each of the molecules. Okay, so if we go back to our mini sketch, so here as these molecules move closer to each other, so this is just an example. So as these molecules, okay, let's say this is a molecule with, this is a molecule, né? And then this is another molecule. Okay, this is another molecule. So it has electrons, right? So we know what the electrons are the ones which actually participate in chemical bonding and in chemical reactions. So here they are saying when the molecules get closer to each other, the distribution of electrons in those molecules will shift, right? So such that there is slightly positive side and a slightly negative side on each molecule, right? So when they move closer to each other, the distribution of these electrons will change. So like this side might be slightly positive, and then this electron will shift to this side. Okay, I hope it makes sense, but then that's the whole idea. When molecules of a compound move closer to each other, the distribution of the electrons will be affected, such that one side is slightly negative and one side is slightly positive, right? So there will be some attraction between this negative and that positive, which is why they're saying induced dipole forces. Okay, I hope it makes sense. If it doesn't, drop me a text lapho ku WhatsApp ngizama ukuyi-explain ngcono, right? So but then it's not important to see in more detail with what's happening with the electrons during intermolecular forces. So then let us just focus more on the concepts with what's actually happening, right? And be able to differentiate between hydrogen bonds and induced dipole forces. Okay, so the molecules attract each other with a weak force, which is why we're saying induced dipole forces. this is the weaker form of the Fundivals forces, the induced dipole forces. Okay, so dipole-dipole forces, when a molecule has a slightly positive side and another molecule has a slightly negative side, the two molecules will attract each other with a weak force. Okay, so here they demonstrate with a sketch with this one has a slightly negative side, this one is a slightly positive side, so these molecules will attract each other with a weak force. Okay, so hydrogen bonds are the stronger types of dipole-dipole forces, right? So okay, here they're just saying, okay, hydrogen bonds we discussed in grade 11, but for the sake of our studies, it is helpful to observe that hydrogen bonds are mostly found between different molecules where at least one molecule has an OH group, right? And hydrogen bonds are present between the oxygen atom connected to one molecule which is slightly negative and a hydrogen atom of a different molecule which is slightly positive. Okay, so here they illustrate what a hydrogen bond looks like. So these dotted lines here represent what induced dipole forces, and then this one, this solid line, it represents a hydrogen bond. Okay, so let us look at an example. So they say identify the intermolecular forces found in propane. So propane has carbon atoms, has carbon and hydrogen atoms only, right? So we know with a hydrogen bond cannot be present here because there's no oxygen atom, right? Remember here, but an oxygen atom needs to be present somehow, or an OH group needs to be present, such that the hydrogen bond, okay, what am I saying? Let me just see with how they discuss intermolecular forces on the exam guidelines. Okay, so let us read through. Intermolecular forces, they say name and explain the different intermolecular forces or Fundivals forces. Dipole forces are forces between two polar molecules. Induced dipole forces or London forces are forces between nonpolar molecules. So these induced dipole forces, it's forces between nonpolar molecules, meaning there's no positive side and negative side in that molecule. So that is why, but the distribution of the electrons is the one which is affected in induced dipole forces. So yeah, but then Tina, we are not much concerned with what's actually happening. This was discussed in more detail with grade 11. Tina, we're just interested in the physical properties, melting point and boiling points. Okay, so I think this section will be easier to explain while we doing questions, right? So let us look at this example. So they say identify the intermolecular forces found in propane. So they say the intermolecular forces found between the molecules of propane are induced dipole forces. Okay, so this is because this is a non-polar molecule. There's no positives, there's no negative side and positive side, there's only sort of like one positive side. Okay, the Fundivals forces or induced dipole forces in this case between the molecules are very weak and are easily broken. This leads to alkanes relatively low boiling points, right? So this is how intermolecular forces affect the physical properties of compounds, right? So when the intermolecular forces are weak, it means less energy is required to break those forces or to overcome those forces between the molecules, right? So this will lead to that compound having a low boiling point and a a higher vapor pressure, right? So we'll talk more about this as we go. So now we have another example. So these are water molecules, right? So H2O, 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 right? So the intermolecular forces found between the molecules of water are hydrogen bonds. The water molecules are strongly attracted to each other by hydrogen bonds, right? So a hydrogen bond will be present between water molecules because the hydroxide group is present, the OH group, right? OH, OH, right? So now in a hydrogen bond, the attraction will be between the O and the H, right? Because oxygen has sort of like a slightly more negative than hydrogen. This one is slightly it's more positive, this one is more negative, right? So the attraction between will be between those two, right? So yeah, okay, now I'm rushing to discuss some questions. I think there's too much to learn from intermolecular forces. I hope you've covered more in class, but then I just want to quickly jump into questions. Okay, so here I have a past paper of 2013. It's paper 2 of physical sciences. So we'll just jump straight into the questions. Okay, so Lanabati, the letters A to F in the table below represent 6 organic compounds. Okay, A, B, C, D up to F. Those are organic compounds. We know with the organic compounds, they have carbon atoms, as we can see. Right, so now Batini 3.1, but write down the letters that represent the following. Alkenes, a ketone, a compound with the general formula HC, CnH2n minus 2, a structural isomer of cyclohexene. Okay, right. 3.1.1, they want us to write the letters. 3.1.1, the letters that represent alkenes, right? So we'll go back to it here. We know what the alkenes will be identified by a double bond, right? So I'll say A and C are alkenes, okay, because there's a double bond between the carbon atoms. So it's A and C, not A and C, A and C. A and C. Okay, so 3.1.2, 3.1.2, Batini, a ketone. Write down the letters that represent a ketone. So a ketone will be identified by a double bond between this oxygen atom and the carbon atom, right? The carbon atom which is bonded to the oxygen atom needs to be in the middle, otherwise it will be an aldehyde, right? So let me sort of like quickly outline with you what is the difference between ketones and aldehydes, because lay in a confuser if you are not careful. So let us say we have 3 carbon atoms, and then the middle one is bonded to the oxygen atom, and then these ones are bonded to the hydrogen atoms, right? So this one will represent a ketone, right? Because it is bonded to a carbon, it is bonded to the carbon atom which is attached to the oxygen is in the middle. But then if the structure was like this, this will be an aldehyde, right? This will be an aldehyde. Please notice the difference, because this can be quite tricky if we are not careful, right? So notice with the carbon atom attached to the oxygen is on the side, so this is an aldehyde, right? Aldehyde, and then this is a ketone. Okay, this is a ketone, right? So 3.1.2, they want us to identify a ketone. So I'd say the letter which represents a ketone is B, right? It's letter B. Okay, letter B is a ketone. Now 3.1.3, they want us to identify a compound with the general formula CnH2n minus 2. Okay, so I know what you're looking from our notes when we were looking at homologous series. We know what a homologous series is a series of compounds with the same general formula and the same functional group, right? So looking at alkanes, alkenes, and alkynes, we know what those are hydrocarbons, right? So there are no other atoms there except carbon and hydrogen. Okay, so now for this general formula here, CnH2n minus 2. If you are not sure, okay, you know what this will be, either an alkane, you know what it will be, an alkane, alkene, or an alkyne, right? So we know what the alkanes, starting with alkanes, we know what, okay, the simplest one is methane with 1 carbon atom, right? And then the second one will be ethane with 2 carbon atoms, right? So the molecular formula for this one will be CH4, right? And the molecular formula for this one will be C2H 1 2 3 4 5 6 H6, right? So I can immediately say, okay, if I have one carbon atom, I will need to have 4 hydrogen atoms. Okay, so I'm just trying to find a way to explain with, okay, how to actually determine this general formula, right? If you are not sure, right? So if you have 1 carbon atom, you'll have 4 hydrogen atoms. If you have 2 carbon atoms, you will have 6 hydrogen atoms, right? So if I have another alkane here, let's say it's 1 2, it has 3 carbon atoms, it will have how many hydrogen atoms? 1 2 3 4 5 6 7 8, right? So it's C3H8. Okay, so what is the general formula then? The carbon atom, if I have n carbon atoms, I will have 2n plus 2 hydrogen atoms. I hope you can see. Here I have 1, right? So if I say 2n plus 2, if I have 1 hydrogen, if I have 1 carbon atom, I will have 2 plus 2 hydrogen atoms, which will give me the 4, right? So if I have 2 carbon atoms, I will have 2 times 2, which is 4, plus 2, which is 6. I will have 6 hydrogen atoms. Same applies for this one. If I have 3 carbon atoms, I will have 2 times 3 plus 2 times 3 is 6, plus 2 is 8. So it will give me this 8 hydrogen atom, right? So I know what this is not an alkane, so which leaves me with alkenes and alkynes. Okay, So the simplest alkene, we know it has 2 carbon atoms, right? So we'll have C, right? And then we'll have 4 hydrogen atoms. So this one, the molecular formula will be C2H4, right? Then if I have 3 carbon atoms, I will have, if I have 3 carbon atoms, I'll have how many hydrogen atoms? I'll have 1, 2, 3, 4, 5, 6, right? If I have 3 carbon atoms, I will have 6 hydrogen atoms. So this, if I have n, it seems like there's a pattern. So in this case, the number of hydrogen atoms is twice as much the number of carbon atoms. So I'll have CnH2n, right? So yeah, this is the general formula for alkenes. Therefore, by a process of elimination, I know what it is an alkyne, right? So the compound which has this general formula will be a compound with a triple bond. So going back to this table here, we see with the compound with the triple bond is compound F. Okay, a compound with a triple bond is compound F, right? So 3.1.3, compound with a triple bond is compound F. A structural isomer of cyclohexene, right? I'm not sure which cyclohexenes are actually part of our syllabus. I've never come across cyclohexenes before, so I think I'm gonna skip that one because we don't have cyclohexenes in here in the exam guidelines. If you check, I doubt it's part of our syllabus, right? If it is, I'll come back to this question, but then for now I'll just skip it. Okay. And then they want us to write down the IUPAC names of compound A, 3.2.1, 3.2.1, compound A. What is compound A? Sorry. Compound A is an alkene, right? So we see with it as a double bond here. The first thing that we need to do is to identify the parent chain. The parent chain will be the one with the most number of carbon atoms, right? So if we go horizontally, starting from the left to the right, we'll see with okay. And then when you count, you start counting from the carbon atom which is nearest to the functional group. So here the carbon atom which is closest to the double bond is this one. We'll start counting from there, right? So let me just oops. Okay, hold on. Okay. So this is compound A. So I want to name this compound, right? So when we count, we'll start counting from the carbon atom which is closest to the functional group. In this case, this carbon atom will be this one. It's the one which is closest to the double bond, right? So we'll say 1, 2, 3, 4, 5, 6, right? So it could be 6, but then we need to find what is 6 the longest, is 6 carbon atoms the parent chain. What I mean is we also need to count this way, and we also need to count this way, going like this and going like this. So for now, I'll just went from right to left, right? So if you say 1, 2, 3, 4, 5, 6, you see what is still 6 is the highest that we get. And if you say 1, 2, 3, 4, 5, definitely six carbon atoms will form the parent chain. So this will sort of have the root of the name will be hex, right? And then now we need to count with, okay, the functional group is attached to which carbon atom, right? So we see with the double bond is attached to the second carbon atom. So this will be 2-in, right? Since it's a double bond, therefore it's an alkene, right? Now we need to calculate the branches. Okay, so we need to determine the branches, right? So here it's 1, 2, 3, 4, 5, 6. So I see that there's a branch attached to carbon number 4, and there's a branch attached to carbon number 5 in the parent chain. That branch has one carbon atom. Those branches have one carbon atom, right? So it means what, okay, this will be methyl. We'll have methyl in our name. So if it was 2 carbon atoms, we'll have ethyl. If it was 3, we'll have propyl, and so on, right? So we will say the name of this compound is 4,5 dash dimethyl hex 2-in, right? Hex 2-in, right? And then we move on 3.2.2. 3.2.2 Batini. Write down the name of compound E. Compound E is a halogen, right? So we see what we have a halogen here. It's a haloalkane rather, because we have halogens here. We have 2 bromine atoms, right? So again, we need to be able to identify the parent chain and count the number of carbon atoms present in the parent chain. Okay, so okay, let me put it here. Okay, so with this one, we also need to identify the parent chain. We start counting from the carbon atom which is closest to the functional group. So we'll count from this carbon atom. So we'll have 1, 2, 3, 4, 5, 6, right? But then we also need to count this way: 1, 2, 3, 4, 5, 6, 7. So we see what is 7 is the longest chain, right? 7 is the longest chain, right? If you count like this, 7 is the longest, right? So now the parent chain has 7 carbon atoms. So we'll have hept in our name, right? Hept. Okay, and then we need to see what, okay, we need to identify the position attached to the functional group. So 1, 2, 3, 4, 5, 6, 7, right? So we see Guti, there's a bromine atom in the second and the third carbon atoms, right? So we'll have 2, 3 dibromo, right? And then next we need to count to identify the branches. We see with it there's a branch attached to the 5th carbon atom. So we'll have 2.3 dibromo, 5 methyl heptane, 5 methyl heptane, 5 methyl heptane, 5 methyl heptane, Okay, 3.2.3, 3.2.3. we need to write down the name of compound F. So compound F is an alkyne. Compound F is an alkyne, and then we need to write down the name. Okay, so again we need to identify the parent chain by counting the carbon atoms. So we'll start from the carbon atom which is closest to the functional group, in this case this carbon atom here. So we'll have 1, 2, 3, 4, 5, right? So and okay, or we could count like this: 1, 2, 3, 4, 5. So we know with the parent chain has 5 carbon atoms, so we'll have pent in our name, right? So next we need to find the position of the functional group. We need to see with, okay, the triple bond is attached to the second carbon atom, right? So we'll have 2 ion. Okay, and then next branches, we have a branch in the 4th carbon atom, and then that branch has 1 carbon atom as well, so it will be methyl. So we have 4 methyl, pent 2 ion. That is the name. Okay, 4 methyl pent 2 ion. Okay. Yeah, so I think I'll just stop here for this video. Okay, you guys are way ahead in class. Probably you have covered the basics of naming organic compounds. We have looked at physical and chemical properties, and you have looked at intermolecular forces, and you have looked at addition, substitution, elimination, chemical reactions. Yeah, we will get there as quickly as possible, but then let us like take things easy. If you have any questions, feel free to drop a text lapho WhatsApp and let me know what do you think of this video. Does it benefit you, or you prefer something else? Yeah, just feel free lapho WhatsApp ungazisi ukuthi kwenzekani. Okay, we'll just stop here for the video.